Wait. Okay, so now the first thing we start with is what we call patterns. Some of you know it as sequences. Now, what is a pattern? A pattern is just basically a list of numbers, sorry, put in a particular order, right? So 1, 2, 3, 4, and so on is an example of a number pattern. Why? Because it is a list of numbers written in a particular order. All right, that's what a number pattern is. Okay, even if it involves negatives or alphabets, you know that it is an ordered list of numbers. Okay, that's what it is. Sharp. So now you are expected to know three types of patterns or sequences. You're expected to know what we call the arithmetic sequence. You guys know it as the linear sequence. You're also expected to know what we call the quadratic sequence. You did it this year in grade 11. And then the last one is what we call the geometric pattern or sequence. We're going to do that. But we start with what we call the arithmetic sequence. I'll explain it shortly, or rather give you the definition shortly. Let us start by an example. Ne? So you've got this pattern here. 2, 5, 8, and so on. Can you guys tell me what are the next two numbers in this pattern? What are the next two numbers in this pattern? 11 and 14. Okay, all of us agreed. The next two numbers in the pattern are 11 and 14. 11 and 14. Now, how did they come to the realization that the next two numbers are 11 and 14? So they looked at this pattern, right? They looked at this pattern, right? And realized that for them to move from 2 to 5, they added a 3. For them to move from 5 to 8, they also added a 3. So therefore, for you to move from 8 to the next number, you add a 3. So that is 8 plus 3 gives us 11. From here, also add a 3. 11 plus 3 gives us a 14. Okay, so that's how they got to those two answers. Now, sometimes it happens that you may not see at outset or with a naked eye rather, whatever, that the number they add between successive terms is 3 or whatever it is. Now, if you can't see that immediately, there's always a shortcut. What you do is you go the next number minus the previous number. 5 minus 2 gives you an answer of 3. This 3 implies that they added it onto the 2 to move to the next number. Let's do that for the 5 and 8. If you can't see how they move from 5 to 8, you just simply go the next number minus the previous number gives you a 3. This is the number they added onto this to get to the next number. So you guys see how you sort of get that number between if you can't see it immediately. Thumbs up if you're happy. Okay, Lulama, you happy? Okay, proper stuff. Bahlal is also happy. The whole congregation is happy. All right, proper stuff. Now, so you guys can clearly see that they adding the same number between successive terms. So it's the number 3. Now, this type of pattern, remember what a pattern is, just a list of numbers, right? Put in a particular order, put in an orderly manner, right? So now, if you come across any like list of numbers, where you add the same number between successive terms, that is what we call a linear pattern. Linear pattern. Let me write it there. This is what we call a linear pattern. Okay, a linear pattern. Now, this word, or rather this name, comes from the word line. Line means straight, like a straight line, right? So this whole thing is in relation to the fact that like you add the same number between successive terms. So we have 3 all over. So line, it's the same thing. It's constant, doesn't change. So that's where the name comes from. Line, linear pattern. Are you guys happy with that connection, the name, line, and the whole thing? All right, proper stuff. But you guys know that mathematicians are very snobbish. So instead of them using the common name that everybody uses, linear pattern, they'll come and say, no, it's not a linear pattern, yeah, it is an arithmetic pattern, because there's no bish. You know that, right? Our Einstein and Newton, even Racho himself, I'm joking. But yeah, so that is the name they normally use. But yeah, you can use either one, still fine. Okay, sharp. Yeah, and another name for, you guys know what another name for pattern is sequence, ne? So just want to put it out there. From this point on, instead of me saying an arithmetic pattern or a linear pattern, I'll say arithmetic sequence or linear sequence. Fere. Sharp, sharp. So now, can you guys find me the next two members of the pattern quickly? Can you guys quickly tell me what are the next two? All right, 17 and 20, ne? Proper stuff, proper stuff, proper stuff. We're all in the same boat. 17 and 20. Okay, Sapang just joined. Sapang, what are we doing? We have started this topic. We started from scratch, Sapang, ne? So we started with this topic, sequences or patterns, and then we are starting with this linear pattern, which is what you did this year, and what I also taught you this year, linear patterns. So I'm just doing an example. We just started now. This is just an example. So this pattern starts from the number 2, and then we add 3 between successive terms. So that's what we're doing. So yeah, you're not late. You're not too late. So yeah, are you happy, Tsapang, with what I just said now? Tsapang Khweng. Yes, Tsapang? Okay, trust that you're good. Proper stuff. Now, you guys gave me the next two terms there. Sharp, sharp. Now, let us what's this? Let us familiarize ourselves with the terminology under patterns. So the first term, the first member of the pattern, the first member of this pattern is clearly 2. But mathematicians, instead of them using this whole phrase, they go T1, term number 1. Term number 1 of the pattern, that is 2. Term number 2 of the pattern is 5. Can you guys tell me what is T 6 of this pattern? Okay, someone says 17. Does the whole congregation of Christ agree? Yes. Okay, all of us agree. Okay, that is 17. Yes, member number 6. T2, T3, T4, T5, and T6. Sharp. You guys remember? Okay, can you guys find me T9? Can you guys tell me what T9 is? T9. I'm waiting for you guys to tell me what T9 is. Someone says 26. The next person says, okay, someone approves. Lulama approves. Lulama Matlo approves. So therefore, T9 is equal to 26. How did we get it? We know that this is T7. This is T8. And lastly, this is T9. So you guys are absolutely correct. Charlie, are you following? Nolo, are you happy? Okay, Nolo is happy. What about Charlie? Washapo, Charlie? Wakushish. Okay, silence means that you are good. Proper stuff. Sharp, sharp. Now, yeah, so now if a question comes and says, can you find us T 100? What? Find us T 100. So this would take you like a long time until you get to it. You're going to have to go T 10, 11, 12, and so on until T 100. Ne? So you'll be pleased to know that there's a shortcut to this. You guys obviously already know about it. So the shortcut is just a general term. It's a shortcut formula for you to find T100. And what is this shortcut? This is the shortcut. I'll write it officially there. It says TN, the member you're looking for, Let's zoom in. It says Tn, the member you're looking for, is equal to A plus open bracket n minus 1 close bracket d. Now, this formula or this shortcut, I repeat, this formula or shortcut, we only use it when we are dealing with a linear sequence or arithmetic sequence, a sequence where you add the same number between successive terms. That's the only time you use it. Now, from this formula, this A represents the first term, the first member of the sequence, while this D represents the constant difference. Constant means doesn't change. Difference means the number you get when you subtract two things. So you guys saw how we realized that they're adding 3 between successive terms. We just went the next number minus the previous number. 5 minus 2. The answer you get when you minus two numbers is what we call difference. Hence, constant, never changing, difference. Are we all happy? Proper stuff. Now, let us go ahead and find member number 100. You remember I asked you guys to find T100? Let us go ahead and use this shortcut to find member number 100. So we're going to go T100 equal to, please note that I replaced the N with 100. So therefore, wherever there's an N on our formula, I put 100. So we just literally substitute into this formula. A is T1. That is the first term in whatever sequence you're dealing with. In this context, our first member is 2, sorry. We put a 2 there. Plus, I told you that wherever there's an N, you put 100 because that's what you did there. Put 100 there, minus 1. And then like D, constant difference, then the constant number you add between successive terms happens to be 3 for this particular pattern. 3. Can you guys punch this into your calculators and tell me what the answer is? If you don't have a calculator, you're like a soldier goes to war without a gun. That is just too much. It defeats the whole purpose of going to war. Waiting. Ke eme ka tetelo. You guys must give me the answer quickly. If you don't have your calculator with you, you must use your brain. Ka se pala ke bana ba ko Asia kwa ba China ba ka se go phala nne ke a gana go tswa Africa mona o ija bogobe straight ka se pala ke batho ba ja noodles. Yeah, let's talk. What is the answer there? 299. All of us got that answer, yeah? Tapang, happy? Proper stuff. Lama, happy? Right. So that's how you sort of use this formula to find terms of this arithmetic sequence. So if they ask you to find T1000, you know exactly what to do. In fact, can you guys find me T77 quickly? T77. Member number 77 of the sequence, quickly. Someone says 81. The next person says, let's all talk. Do you all agree? Bashala, we're just looking for T77. Okay, we all agree, yeah? All right. God is great. Let's push. So we just substitute in that formula. We have this A represents the first member of the sequence, which is 2. You guys remember, 2 is the first member of the sequence, and plus So now we substitute n. N is like whatever we put there. So it's 77. N is just the position of what you're looking for. So we're looking for the number that's positioned number 77. So that's what n is. And then this one is our constant difference. That is the number we add between successive terms. And it gave us 81. My friend says it gives us 81. That is wait, give you how much? 230, ne? Isn't it 230? Check where you might have gone wrong and fix it. I'm gonna wait for you to fix it.